Hi, everybody. We're going to talk about your favorite topic, complex numbers. Okay, so the standard form of a complex number is a plus bi, and we call it a complex number because it's made up of a real component plus an imaginary number. So they become complex. Okay, some examples would be like 2 plus 3i or negative 1 plus 7i, or 3, because it's technically plus 0i, or 7i, because you're technically adding 0 to that imaginary number. Okay? So remember, I is equal to the square root of negative 1. And so I squared would be the square root of negative 1 times the square root of negative 1. And when you square something, a square root, you get the square root goes away and gives you negative 1. I cubed would be the square root of negative 1 cubed, which we can break up as the square root of negative 1 squared times the square root of negative 1. So the square root of negative 1 is negative 1 times the square root of negative 1, which is I. That's I. So this would be negative I. Okay? The square root of negative 1 to the fourth power is like the square root of negative 1 squared times the square root of negative 1 squared. The square root of negative 1 is negative 1 times negative 1, which is 1. That's amazing. Okay, so the square root, the I to the fifth power, we can break that up as the square root of negative 1 to the fourth power times the square root of negative 1. That equals 1, so we just get I to the sixth. Let's see, square root of negative 1 to the fourth power times the square root of negative 1 squared. That equals 1. So just the square root of negative 1 squared would give me negative 1. Okay, the seventh, square root of negative 1 to the fourth times the square root of negative 1 to the third. When I have the square root of negative 1 to the fourth, that equals 1. And then the square root of negative 1 cubed is like I cubed, so that equals negative I. Lastly, the square root of negative 1 to the fourth times the square root of negative 1 to the fourth gives me 1 times 1, which is just 1. This pattern just keeps repeating over and over and over and over. So we get I, negative 1, negative I, 1. I, negative 1, negative I, 1. So that's a fun fact. We're going to do some complex number maneuvering here. Okay. So first we're going to add and subtract. Go ahead and pause and try these on your own. Here's what I got. 3 plus 2 is 5, and negative 1 plus 3 gives me positive 2i. The next one, I see that these cancel plus and minus, so I just get negative 4. Now pause and try multiplying. All right, so you got to take the square root first here. So I get the square root of a negative is I, and the square root of 4, you can break them up, negative 1 times 4. I get 2i times the square root of negative 1 times 4 times 4i, which gives me 8i squared. What does I squared equal? Equals negative 1. So this is 8 times negative 1. This is negative 8. All right, next, we need to either area model or FOIL. So 8 or distribute. Okay. 2 times 4 is 8. 2 times 3 is plus 6i. I times negative I times 4 is negative 4i. Negative I times 3I is positive, nope, negative 3I squared. Combine my like terms. 8 plus 2I minus 3. Okay, remember, I squared is equal to negative 1, so I'm going to replace it times negative 1. And we get 8 plus 3 plus 2I, which gives me 11 plus 2I. All right, last one. I'm going to go ahead and multiply again. 3 times 3 is 9. 3 times negative 2 is negative 6I. 2 times 3 is positive 3I. And 2 times negative 2 is negative 4I squared. I made a mistake. Okay. 2 times 3 is 6I. Okay. These cancel in the middle, leaving me with 9 minus 4 times negative 1, since I squared is equal to negative 1. So I get 9 plus 4, which is 13. Notice we multiplied these two factors together and we came out with a whole number, like a whole real number. So, or we multiplied these two complex factors together and came out with a real whole number. These complex numbers here are called complex conjugates. They have the same leading term, real term, and then the complex numbers, one is positive and one is negative. So this is kind of like a complex numbers difference of squares, okay? When you multiply complex conjugates, you always come out with a real number. So tell me, what is the complex conjugate of 3 minus 5i? That would be the complex we're going to multiply. The complex conjugate would be 3 plus 5i. So just only the I terms are opposite signs. So we can say complex conjugates are a plus bi and a minus bi. All right, I'm going to go ahead and multiply. 3 times 3, 9. 3 times 5i plus 15i minus 15i minus 25i squared. Middle terms cancel. I get 9 minus 25 times I squared is negative 1. So I get 9 plus 25 gives me 34. All right, we don't really divide complex numbers. What we do is we rationalize the denominator. So we're going to multiply the fraction by the complex conjugate of the denominator. All right, so first I'm going to set us up. Let's put these in parentheses. All right, we're going to multiply by the complex conjugate of the denominator. So that would be 4 plus 2i. And anything I do to the bottom of the fraction, I better do to the top. So I'm going to multiply the top as well. Here we go. So you got to multiply out the top and the bottom. I'm going to start with the top. So I get 2 times 4 is 8. 2 times 2i is plus 4i. 3 times 4 is plus 12i. 3i times 2i is plus 6i squared. On the bottom, we get 4 times 4 is 16. 4 times 2i is plus 8i. Negative 2i is times 4 is negative 8i. And negative 2i times 2i is minus 4i squared. The bottom better figure itself out to become a real number. If it doesn't, we did something wrong. Okay, so the middle terms cancel out, and I'm going to start with the bottom to make sure it comes out to a real number. So 16 minus 4 times I squared is -1, so times -1. Looks like we're going to come out to a real number. I'm going to simplify the top. We get 8 plus 4i plus 12i is 16i, and then plus 6 times -1 for my I squared. And I get, so 8 minus 6 is 2, plus 16i over 16 plus 4 is 20. I can divide the top and the bottom by 2, giving me 1 plus 16 divided by 2 is 8i over 10. And we are done there. All right. So, plotting complex numbers is just like plotting like an ordered pair. So this axis is going to be my real axis, A, and my BI axis. Okay? So, in the x direction, or in the real direction, we're going to move over 2. Remember, this is my A, 3 is my B. Move over 2 and up 1, 2, 3. Okay, 4 is my A component, plus 0i. So my B component is 0. So I'm going to move over 1, and we'll just label it. This is my A. This is 1, 2, 3, 4. And that's example B. We're done. See ya.